Hello, hi. I am Kavinessnah and my matrix number is 195837. So today I would like to explain about the fluid characteristics and dimensional analysis. First of all, let's look for the fluid characteristics. And before that, let me explain to you what is fluid. Fluid is a substance which can flow. Technically, the flow of any substance means the continuous relative motion between different particles of the substance. The continuous relative motion between the particles of the fluid when shear force is acting on it. The the particles of fluid must pass each other when shear force is applied because they cannot resist the shear force. For example, the characteristic is they are inelastic to shear stress. A fluid can deform when under shear stress and indefinitely without returning to its original position. So next we will look for the type of fluids that we have. So we have two types of fluid, which is liquid and gases. The main difference between these liquid and gases is that basically the volume of a fluid remains definite under any shape or on the surface or in when it's come into contact. But gas can occupy completely space available in the container in which is kept but have a compressible volume, which means it can a volume of a gas can be compressed. Next we will look for the density. So let's see what is density is. Density is mass per unit volume. So basically the units are is kg per meter cube. So from the ideal gas equation we can derive to P equal to rho RT, which is P is pressure, rho is density, R is gas constant, and T is temperature. So we can derive as we can see here. It's from P equal to mv over RT. Next, we'll look for specific volume. Basically, specific volume is the inverse of density. So as its inverse, it is volume over mass. You can see here it is the inverse of density. So from here to ideal gas equation, PV equal to nRT, we know that n equal to m over molecular weight. So V equal to V over m equal to RT over PM. So m here is, so the unit of this specific volume is meter cube per kg. Next we will go for specific weight. As we know it's sound about weight, it is definitely influenced by weight. So specific weight is the weight per unit volume. So the unit will be kn over meter cube. So commonly we use a value of specific weight is of water at the on the earth at 4 degrees Celsius. So it is 9.807 kilonewton per meter cube or 62.43 pound f per feet cube. So specific gravity is the next. Gravity it is the specific weight of a given fluid over specific weight of standard volume. So usually the standard volume is water. Next we will go for viscosity. Viscosity is the resistance of a shear stress, which means how resist is the fluid to flow. If it is a high viscosity, uh, its flow slow. That is how it works. So viscosity decreases with increase in temperature for liquid, and for gas it is as viscosity increases, the temperature increases. Next, we will go to the next subtopic, which is dimensional analysis. So let's see what is dimensional analysis is. So dimensional analysis is the simplifying a physical problem by applying to dimensional homogeneity to reduce the number of relevant variables. Basically, we have to solve a question with many variables. So we use this dimensional analysis method to solve the equation by reducing the number of variables. So from here we can see that we can use for presenting and interpreting experimental data, detecting problems that not able to direct theoretical solution. We can also check the equation, physical establishing the relative importance of particular physical phenomena, and physical modeling. So this dimensional analysis, we have two methods that we can use to solve the questions, which is Rayleigh method and also Buckingham's pi method. Firstly, we'll look for the first method, which is Rayleigh method. So I would like to explain a bit about this uh, method. So this method is finding a functional relationship with respect to the parameter in the interest. So you can read this. We have some steps to solve using this method. So let's see detailedly by using an example. So the question is Ft, drag force, is the function of mu, viscosity, v, velocity, rho, mass density, and d, diameter of sphere of a fluid flow. Determine the function. So which means we have to simplify this. Basically, the first step that we have to do is we get the derivative, which is for Fd it is m times t over t, and we can make it simple by t negative 2. Next, velocity equals to length times t negative 1, density equal to m times length negative 3, mu, which viscosity equals to m times length negative 1 times t negative 1, and next is the simplest, density equal to t. L. So let's move for the next step. We have a number of variable which is v, rho, mu, and d. So we have to raise up everything to one unknown. So we get this Fd equal to k is the constant that we would find. This is the f, we change to k, so it will be equal to v power of a, rho power of b, mu power of c, and d power of d. This is unknown, so you can put as what you want. So next we will turn this into we will substitute the previous equation that we made into Fd equal to m times L times t negative 2, and velocity is L times t negative 1, rho is m times L negative 3, mu is m times L negative 1 times t negative 1, and distance is L. So now we will equaling, if this is the equation, we can equal left and right. So for m, this is the power of 1, so it is 1. For m, we have b and c, so it's b plus c. Next, for L, we have 1, this is power of 1, it is in a, which is 1, so it's a, and negative b, and then c plus d. And then for t, we have negative 2 from here, and negative a, negative c. So we can simplify this equation, and we will get something like this. So we substitute each into these variables. From here we substitute a, b, c, and d. Then we will move everything, that is we have a value into the left and the unknown into the right. So we can power everything to c as we assume all equation equal to c. So now we have to check whether this equation is dimensionless or not. From here As we checked, it's already dimension, which is we get 1 here and 1 here. So we can conclude this is the finalized equation. Next, we will look for Buckingham's pi theorem with the same example as I mentioned before. Buckingham's, so you can read here. We use pi form to solve this question. So I can directly go to the example as the previous example. I use the same example so you can know the difference between these two. So we have some steps to solve in Buckingham's equation. Firstly, we have to count how many variables that we have. So as we know, we have velocity, distance, viscosity, um, density, velocity, and two more, which is FD. So as we know, we have to simplify this into this form, and then we count how many dimensional quantities, which means we have mass, length, and time. So next, so we have 3, so we have to minus 5 into 3, then we get 2. So this is the number of pi number that we have. So we have to select repeating variables. With repeating variables are the things that have something in common. So something that is cannot be dimensionless, and there have no two repeating variables that can have the same over dimension. So we have a general repeaters as in theory. I'm sorry, wait for a minute. So we have density, velocity, and distance. So I pick it because it is easier to solve. So first we use the first pi. We choose the repeaters, density, distance, and velocity. We have another two, which is Fd and mu, which is viscosity. So we will times the Fd. From here, we do the derivation here until we put x, y, and z. So this is the power of 1. So we have to give a solution. So for m, we have x plus 1 from here, and then for L we have negative x plus y plus z plus 1. So we have to do one by one. For t we have negative z and negative 2. So we can easily get the pi 1, which is equal to fd equal to pt cube v cube. So when we cancel, we put the derivation and we cancel it, we get its dimensional. So that is for. So we have to find another pi by using the, which is viscosity, the same method we apply here, and then we get pi 2 also a dimensional. So the equation that we can get is pi 1 equal to f pi 2. So you put pi 1 everything here and f equal to pi 2 everything here. So you will get the equation, the final equation. So that's all from here for this episode, the end. Thank you.